Hello, this is Karthik Krishnaswamy, and today we're going to take a brief tour on deploying 802.11ac networks using AirMagnet Survey. AirMagnet Survey is the industry's first W-line deployment solution that enables users to measure as well as assess true end-user experience of an 802.11ac W-line network. The product goes beyond just verifying RF coverage by plotting actual end-user network performance in terms of throughput, taking MIMO and other environmental situations and network configurations into account. AirMagnet Survey clearly shows the coverage of specific 802.11ac parameters that boost performance, such as higher MCS schemes and wider channels, and where interference and legacy components may impact 802.11ac performance. The end result is a complete Wi-Fi weather map of all critical RF and end-user performance metrics. I'm going to give you a brief overview of the key capabilities, as well as explain how these capabilities would benefit you as you deploy your 802.11ac network. Let me go ahead and open a project that has all the relevant survey data that I can use to demonstrate the key features of deploying 802.11ac network using AirMagnet Survey. This project consists of both active as well as passive surveys. Let me go ahead and take a look at the passive survey. As I select, the application processes all the data that was collected as part of the survey. In order to generate different kinds of heat maps, starting with the signal strength heat map. Let me just go ahead and select just the 5 GHz band because that's the band that we are interested in for 11AC survey. As you can see here, we see very high signal strength here in this area of the floor and lower signal strength here. And as I hover over, you get critical information about the AP MAC address of the AP, the signal, noise, as well as the predictive fire data rates. Let's go ahead and take a look at a coverage map of the predictive fire data rates for our network. We see that because of the presence of 802.11ac APs in our network, we see very high predictive fire data rates. We see data rates close to 800 megabits in some areas, and we see lower data rates close to 200, 400 megabits in other areas. We can also visualize channel width coverage map. 802.11ac introduces 80 megahertz and 160 megahertz wide channels. Using this coverage map, you can clearly see areas where 20 megahertz, 40 megahertz, 80 and 160 megahertz wide channels are supported. In our area here, we see both support for 80 megahertz wide channels as well as 20 megahertz wide channels, where legacy clients can be supported. If I hover over the floor plan, I get variety of information about the AP name, the predictive fire data rate, the operating mode, channel width, MCS index, as well as the transmit and receive streams supported by the AP. This visualization enables users to develop a channel plan in order to take advantage of 802.11ac's expanded channel widths. 802.11ac designates one channel as primary. This is the channel that's used for transmission at a specific bandwidth. On the left hand side, we can clearly see the channel that's being set as the primary channel, the bandwidth used for transmission, as well as the range of channels that is needed to support this bandwidth. It is important to ensure that there is no overlap of primary channels, as that may cause interference which may impact performance. And that brings us to the channel overlap coverage map. AirMagnet Survey Pro indicates where primary and secondary channels interfere with each other and hence where performance may be impacted. We see in our area here that there's no overlap of primary channels, but there is overlap of secondary channels. This is broken down into overlap channels with 40 MHz wide spacing and overlap secondary channels with less than 40 MHz wide spacing. When an AP falls back to channels with 40 MHz wide spacing, the impact is not as much when the AP falls back to 20 MHz wide channels. Armed with this information, users can adjust channel allocations and AP location to maximize performance for all clients and thus minimize user complaints. We can also take a look at the AP operating mode coverage map. This gives us a good indication of areas where legacy clients can be supported, like such here, as well as areas where high throughput can be achieved. Let's go ahead and take a look at an active iPerf survey that was performed as well. With an active iPerf survey, you can actually visualize iPerf throughput both uplink as well as downlink. Let's go ahead and take a look at the iPerf downlink throughput. From this coverage map, it is very clear that the actual throughput that would be realized by the end user is much less than the predictive file data rates that we saw earlier. This could be because of a variety of reasons: hardware limitations, interference from secondary channels that we saw earlier, as well as overhead needed to support 802.11 protocol. This is the only tool that measures the ultimate user requirement throughput and thus can give you an accurate picture